Let's look at example 7. This is a 4th degree polynomial, so I know that I'm going to have 4 solutions, and I also know that I could potentially have 3 turning points. Remember that it has at most n minus 1, so 4 minus 1 is 3. Let's take a look at Desmos. All right, I'm here on Desmos, and here is my graph. It looks kind of like a W shape. It does look nice and symmetric, but notice that that axis of symmetry is at a line of x equals 2 and not the y-axis. So that means it is not an even function, even though it's an even degreed function. I see zeros at -1, at 1, and at 3, but notice that this one at 1 is a bounce. It goes up and then comes back down, so that is considered a repeated solution. So we have a total of 4 solutions. So all of our solutions in this case are real, one is just repeated. Then I see that one of my solutions, that same one at 1, is also a local maximum, and I have local minimums at -0.4, -4, and a local minimum at 2.4, -4. So I do have 3 turning points here. Let's go ahead and take this information back over to our graph, and we'll identify our increasing and decreasing intervals from there. We had x-intercepts at x equals -1, 1, and 3. And remember that the one that occurred at a +1 was a bounce, so we'll need to take that into account whenever we draw our graph. We also know that we had a local maximum, happened to be one of our solution points. Our local maximum was also at that point 1, 0. And we had a couple of local minimums. Remember, we had 3 turning points total this time. It was at -0.4, -4, and there was another one at 2.4, -4. So we can plot those points as well, here and here. Okay, so we can get a rough sketch of our graph based on that. We know that our arrows were both pointing up. So we are going to come down, hit this point, turn, bounce off the x-axis, turn one more time, and then continue up. So something like a W shape. You can label your points here if you want to. I'm choosing not to just because it's going to be a little cluttered if I do. I am going to go ahead and circle this local maximum since I already had a purple dot there. I want to go ahead and just kind of call attention to that. Now we will talk about increasing and decreasing intervals. So I'm going to go ahead and list both, and I'm going to have 2 of each. So I'm going to have an increasing interval and leave myself room for 2. And then I have my decreasing interval. And again, I'm going to have 2 of those as well because I notice that I have 3 turning points. That means I have 4 different intervals total. This time I'm going to start with my decreasing interval because that's what happens first. I am decreasing first until I hit that point at an x value of -0.4. So starting at -infinity, because that's where we always start, we are decreasing, and then we turn at -0.4. Once I do that, I am increasing. So decreasing here. And then when I get to this point right here, kind of a critical location, I'm going to start increasing. And I'm going to increase until I get to 1. 1 is a turning point, happens to also be where my 0 is located, and it is the local maximum. So I have an increasing interval. Let's label these. This was decreasing over here. And then I have increasing in between -0.4 and a +1. So this is increasing. So from -0.4 to a +1. Again, wherever I left off on my decreasing is where I have to start on my increasing. So now I've said that I'm leaving off on my increasing at 1. That means that I decrease from there. So starting at 1, I am decreasing until I get to that value of 2.4. So this little interval right here was a decreasing interval, and it started where I left off at 1 and it continues until I get to an x value of 2.4. Remember, y values don't ever come into play here. I am not reporting -4 at all, other than in my local maximum or local minimums in this case. Finally, I have one more increasing interval that starts at 2.4, where my decreasing interval left off, and I never turn back around, so that goes to infinity.